Welcome to AP Calculus. The questions on the homework, my guess is that there were some questions on number 27, the one with the absolute value. Shall we talk through this one? Okay, when the absolute value kicks in, here's my coaching for you. Take a look at, sorry about that, my daughter wants to transfer money onto her credit card. Okay, so without the absolute value, the x squared minus 9, just be a parabola, x squared minus 9. But look at what happens when you put the absolute value in there. The part of the graph that's below the x-axis flips up to the top. So when they're asking you to do number 27, they're asking you to find area 2 plus area 1. Orange plus green. So notice how I got the orange area. I took the integral from 0 to 3, which would be negative area because it's below, but I just take the opposite of the area from 0 to 3, and then the area from 3 to 4 I just take as is. So I have to break it up into a two-part problem. So area 2 comes down here, came out to 18. I take the opposite of negative 18 was 18. And then the green area came out to be 10/3. So that's how you handle it with the absolute value. Yeah, Jeff.
Can you explain what you're supposed to do again?
Well, what you're supposed to do is break it up into two parts. The part that's negative has to be multiplied by -1 to make it positive. And the part that's positive, you just take it as is. You have to treat it as a two-case problem.
How do you know from the interval 0 to 3 and then 3 to 4?
So if you're doing it from
Based on the graph. If you were to sketch the graph of y equals x squared minus 9, which by the way is a parabola with an intercept at -9, where's the 0? Where's the intercept? Well, 3 squared minus 9 is equal to 0. So the intercept is at 3. So the boundary between the negative area and the positive area is 3. That's how you know to divide it up into part 1, which goes from 0 to 3. That's the part that comes out as negative area. So to honor the absolute value, we've got to multiply that part by -1. And then the part that's positive, we just take as is. We'll work some more with that today. You experienced that as a challenge problem on the homework that was due today. It's like, whoa, what's going on? Well, we've dealt with signed area. That's negative area, this is positive area. If the problem calls for all positive area, then you're going to have to do something, and that something you do is multiply by -1. So, the next activity, it's a dual purpose activity, trying to get you prepared not only for the semester exam, but also the AP test, is problems 6 through 10 on the no calculator part of that AP test we've been working on. So clear your desks, surfaces off your desks. In fact, I would like you to even take pens and pencils off your desk. I want you to strategize and just take a minute, literally 1 minute, to look through problems 6 through 10. I want you to tell me in what order would you attack them? Problems 6 through 10. In what order would you attack these?
I don't think my name's Sam.
So that you do them in order of how much time it takes. Look at problems 6 through 10. Look at problems 6 through 10 and write down the order in which you would attack them if you wanted to go from the least amount of time up to the most amount of time. Which one goes fastest? Which one's going to take the longest? Oh boy, we've got issues. Sorry, sweetie. I'm teaching that. Okay, does anyone have a suggested order? What order would you take these in? Just sequence the numbers 6, 7, 8, 9, and 10 for me. Although I don't want you to really try number 10 yet, because there's something we need to learn. We'll do number 10 today. But in what order would you do 6, 7, 8, and 9? Which one seems like it would take the least amount of time?
7.
So you do 7 first, and then what?
6. And then 9.
Okay, class, Try it, see what happens if you go 7, 6, 9, 8. Try those 4, then we'll do number 10 together. Loose into this. However, I'd actually like to see how far you can make it through number 12. Try number 12, based on the example I just gave you. I'll work it at the board, you can work it at your seats, and we'll see if we agree. Oh, by the way, does anyone have a suggested use substitution for problem 12? Raise your hand if you have a recommendation for a U on problem 12. Okay, Will?
1 minus x squared.
Yeah, that's the one to go with. Class, try U equals 1 minus x squared, take it from there. By the way, my lower limit converted is 1. What is the new upper limit of integration going to be?
0.
It's going to be 0.
Oh, so it's half, yeah.
Correct.
Now, I'm going to let you in on a secret that is actually part of today's lesson that comes up a little bit later in about, it's like 10 minutes earlier than I would have ordinarily told you. But there is something you can do to shorten things up whenever the lower limit of integration is a bigger number than the upper limit of integration. There's actually advantages to one of your limits of integration being the number 0, and for that 0 to be down here. There will be times when you want to flip the order of the limits of integration. You can actually do that. It's a doctoring up of the problem that can be counterbalanced. So even though I did follow through like this and got 1/3, and well, you know what? 1 to the 3/2 is 1. So I took -1/2 times -2/3, the 2's cancel, I got 1/3. But the truth is the fraction work is not the easiest to navigate. So I want to show you an alternate pathway you can take that takes a lot less time and is much less likely for you to mess up. So I'm here to tell you that you can flip the limits of integration. You can trade them. Instead of 1 to 0, make it go from 0 to 1, as long as you agree to counterbalance that by multiplying by -1. That actually changes the sign, so it'll be a positive 1/2 u to the 1/2 du. That's an advantageous change because it makes it much less fraction work. So, especially when you're on the no calculator part. So, when you change the order of limits of integration, you can do that as long as you agree to multiply your answer by -1. Basically what I'm saying is this. What I'm saying is that if you have the problem integral from 3 to 8 of f of x dx, you can change it to the integral from 8 to 3 of f of x dx, as long as you multiply your answer by -1. You can change, and so, now, no one would really want to change an answer that doesn't have negatives into one that does have negatives, but this has a negative sign in it. You can get rid of the negative sign by simply flipping this. So now we have 1/2 times u to the 3/2 multiplied by 2/3 from 0 to 1. And to make it even more streamlined, you can pull the 2/3 out. Jack and Will, did you guys get this? To make it even easier, you can pull the 2/3 out to make it 1/3 u to the 3/2 from 0 to 1. And the amazing thing here is that you don't even have to do the 0, because that's going to be 0. It's just 1/3 times 1 is 1/3. So there's fewer bumps in the road when you decide to change the order of the limits of integration? Do you feel that there's fewer speed bumps? Isn't it nice when there's fewer speed bumps? Have you noticed the speed bumps out here are not as tall as they were in the fall? It's like you had to really slow down for a while to go over those speed bumps. But now it's like they're settling down. People have gone over them and they've smushed them down. Am I advocating people going really fast now through here on this? No, I'm not. 10 miles an hour, that's the speed limit. But used to have to go like 2 miles an hour. Now you can actually go 3 or 4 miles an hour. Yes, you go ahead.
Multiply negative half by, can you do that, or should you?
You mean to pull it?
Yeah.
You could, I guess.
Yeah.
But I ordinarily don't recommend that. Class, try number 13. So number 13, I'm going to pause the camera, then we'll come back and see how you did. Number 13 is yours. All right, so it sounds like some of you are done. Again, the new limits of integration are 1 and 9. And the antiderivative gives you 1/4 2 square root u from 1 to 9. These numbers are pre-cooked. Just 2 square root of 9, which is 3, minus 2 square root of 1. 6 minus 2 is 4. 1/4 of 4 is 1. That's another option. So when your son or daughter turns 1, you can do something original, something that I didn't do. You can put this symbol in frosting right on the cake. How old are you today? I'm the definite integral from 0 to 2 of x over the square root of 1 plus 2x squared dx, years old. And you might be thinking, well, won't that scar my child psychologically? No. Does this child look scarred? She's happy. I'm happy. 0 to pi over 2, sine x dx. That's the way to go. You've got lots of options for expressing the number 1, and that's exactly equal to 1. All right, and now number 14. Problem 14 looks strange. Would you agree it looks strange? Yeah, it's like they're giving us this random fun fact that the definite integral from 4 to 12 f of x dx is 20. Oh, thanks for telling me. I have to find out what this is. And it seems hopeless until you think to yourself, well, I don't know what to do, but I can do a u substitution. I can let u be 5 minus 2x.
Oh, wait.
So we're doing problem 20.
Oh, it's all 1.
In which, in problem, actually, we're doing problem 14, in which they tell us that this is true. And then they say, based on this fact, can you find the value of this definite integral? Well, I can do a u substitution, in which case du would equal what? Can you help me out, please, Eli?
I don't know. -2.
There's more.
dx.
-2 dx. So let's doctor this problem with a -2. With what do I counterbalance it? Help me out, please. U.
-1/2.
-1/2. So let's look at the new limits of integration. This problem becomes -1/2 times something f of u du. What is the new lower limit of integration? When x is 1/2, the corresponding value of u happens to turn out to be what? 4, of all things. Any guesses as to what the new upper limit of integration is going to be?
Oh, negative.
Let's see if it really, we're hoping for 12. -7/2, that's going to be 2's cancel, 5 plus 7, I'm sure enough it's 12.
Yes.
So, question for you.
Let's go.
If it's true that definite integral from 4 to 12 of f of x dx is 20, what would you say the definite integral from 4 to 12 of f of u du would equal?
10.
Wait, did you listen to my question? If all I do is change the x to a u, is that going to make any difference? I mean, does it really matter which letter of the alphabet we use? No, f is a function, and any variable can be used to represent the input to the function. That's 20. That number is 20. So now the question is, what's -1/2 of 20? I would argue that the majority of people on this planet believe it's -10. -10 is the answer to problem 14. Any questions on this one? Now, switching gears. By the way, you're now prepared to do assignment 4.6, which is due tomorrow, but because of the snow day, we're going to try to get a head start on the next lesson. So, in the 19 minutes that remain, we're going to keep going so we can get caught up, because we've got to be caught up by the end of the semester. You now have what you need for the homework that's due tomorrow, assignment 4.6. So, let's jump into the next lesson, which is lengthy. We need a head start. And would you please do me a favor and flip to page 2.
Are you collecting the AP test?
Yeah, okay, so while you're working on page 2, which is a set of review problems, I'm now going to go around the room to collect the AP test, and Eli, we gotta get yours in the same file. So, here's Sam's.
What is this?
So, this is 4.6. Would you please turn to page 2 and do problems 7 through 12 as a set of review problems? You may begin. We're going to turn off the camera for now. Okay, friends, we need to talk. This is an empty canoe problem. There's nothing in the canoe. Sine squared theta plus cosine squared theta is 1. Sine squared n plus cosine squared n equals 1. There's nothing in the canoe, so it's just x plus c. If you did anything else with that, then know that this is all you have to do with problem 7. It's an empty canoe. This is number 1, right? That is the number 1. And its antiderivative is the family x plus c. Do 8 through 12. Oh, question, Adam?
The same answer if it was asking for dn.
Oh, dn, then it would be n plus c. If it were dn, the answer would be n plus c. But since it's dx, the answer is x plus c. Okay, do 8 through 12. Although, honestly, in order of difficulty, 8 is actually the hardest. You might want to go 12, 11, 10, 9, 8. I'd recommend going backwards. Cameras on. Starting with number 12. Who thinks they got number 12? Be willing to report the answer. All right, Cindy, tell me what you got for number 12.
1/3 times u to the third and times w to the sixth and times v to the cube.
Yeah, so plus c, thank you. So nothing happened to u to the third, w to the sixth. They're constants. It's like they come out front. Nothing happens to them. All you have to do, the only calculus you have to do is take the antiderivative of v squared with respect to v. So that's v cubed over 3. So that's why Cindy has a v to the third over 3. U cubed and w to the sixth just come along for the ride. And this one is also kind of nice because you just treat that as a constant. So it's quantity 4x plus 5 gets multiplied by y plus c. Now here, there is a matchup between x and that. So we've got 4x squared over 2 plus 5x plus c. That can simplify to 2x squared plus 5x plus c. Likewise, that's just a constant. Empty canoe, tangent squared x times y plus a constant. Now, number 8 was probably the most challenging of these. What did you do on number 8? All right, Adam. Oh, I thought you were raising your hand. What ideas do you have for number 8? It's the hardest one of the bunch. Yeah, go ahead.
I just kind of rewrote it as sine squared x with cosine squared x.
You know what? I think a rewrite is good, but instead of using, I would use 10 in one section. Will, did you use 10 in one section to rewrite it?
Could you do like 2 tangent times tangent?
You know what? Yeah, and that's not going to work because the antiderivative of a product is not the product of the antiderivatives. The only way to go is to use tan in one section. Don't freak out. It's not cancer. You're just tan in one section. Winna?
I did secant squared x minus 1.
Yeah. If tangent squared x plus 1 equals secant squared x, I told you the tan in one section story, didn't I?
No. I get it.
Wait, I didn't tell you the story about when I rode my bike to my parents' house up in Wisconsin? Well, that's weird, because
Oh.
1 year after I'd been married, I got this idea in my head I was gonna drive from Wheaton, Illinois to Waukesha, Wisconsin. I put on these bike gloves. Actually still have the bike. I always carry the bike gloves with me for moments such as these. But the bike gloves I was wearing that day, it was about 30 years ago. These are the same bike gloves. And when I got to my parents' house, my dad watches these videos. I'm sure he's probably going to comment on my YouTube channel, because he remembers the day that when I showed up after having biked all day, and I was so tired, I just went to bed, woke up about 24 hours later, and Winna, I'm telling this for you. I'm telling you this story for you. I started freaking out because I got in the shower and I'm realizing there was this like spot on my skin, the back of my hand. I'm thinking, oh no, I've got skin cancer, I'm gonna die. I realized, no, I'm not gonna die. I'm just tan in one section.
Oh.
So, that's what you gotta remember. When I say go, I'd like all of you to say out loud and in unison, don't freak out, you're just tan in one section. Ready? Go. Don't freak out, you're just tan in one section. This was this section right here, where all the, I got a little sunburn on that section of my hand. I thought I was gonna die. Based on tan in one section, you can rewrite this as secant squared x minus 1. Now, when you take the antiderivative of secant squared x, what do you get, class? It's tangent x. What's the antiderivative of 1?
X.
So the answer is tangent x minus x plus c. So know your Pythagorean identities. Sin will cost you 1. I mean, sine squared x, sine squared theta plus cosine squared theta equals 1. That's not really Reformed theology. Tan in one section, and do you know the one for cotangent squared theta plus 1 equals cosecant squared theta? I haven't told you this mnemonic device. You gotta be kidding. Cosecant squared theta plus 1, whoops, 1, that other identity is 1 plus cotangent squared theta equals cosecant squared theta. When I first came to Stevenson High School in 1988, the pre-calc classes were using the following mnemonic device to get students to remember this. It was lamer than lame. Wesley, do you know what it was?
It was lamer than lame.
It was 1 coat in the closet. I'm like, really? Can we do better? So the next iteration was this: 1 coat in the closet. They put a little C sound on there. And that was funny for like 8 seconds. It got old really fast. So then we said, you know what, we can do better than 1 coat in the closet. How about 1 coat on the casket? It's like, ooh, morbid. Yeah, it's really attractive. But then people are like, does everything have to be morbid? So can't we have just one non-morbid thing? You know, oh, I'm gonna die. No, you're just saying, it's cancer. No, can't we have anything that doesn't have to do with death? So here's what we came up with. You ready for this? Will, you ready? Will, you ready for this? This is the one that stuck. 1 cottage in the Cascades. The mountain range, the Cascades. I mean, you can imagine it, just a cottage, smoke coming out from the chimney. Why is the smoke, what's burning in there? It's breakfast. It's not morbid, it's just breakfast. They're cooking breakfast. When I say go, I'd like you to say in a relaxed tone of voice. It's like, oh, what a relief. It's not a morbid example. When I say go, I'd like you to say 1 cottage in the Cascades. Ready? Go. 1 cottage in the Cascades. So those are your mnemonic devices. They come in really handy when you're doing calculus. Question, go ahead.
I like the cat.
Oh, a casket? A casket is a box where in American culture, yeah, so like when someone dies, they often put the body in a casket before they bury it.
Oh.
So, caskets.
Wait, is it just a copy of the casket? I think I'm between a copy of the casket.
Yeah, okay, so maybe I'm describing confident casket, I don't know. And I guess in my mind they're synonymous. So maybe you should just Google it to find out what it really is. All right, here we go. Okay. Caskets. Ladies and gentlemen, tell you what, eyes up front, there's some more we have to do. Some of you have some sidebar conversations going on, table those. We're gonna work hard for these last 6 minutes. A definite integral is an antiderivative. So, I don't know if you ever heard of this concept of saying, oh, you're not gonna use calculus in the real world, but at least you're gonna develop your critical thinking skills. Okay, well, if you're gonna think, you gotta use words. So what are the words behind calculus for a definite integral? One, you can say it's a limit of a Riemann sum. Limit of a Riemann sum. Another way to think of a definite integral is a net accumulation of signed area. The area above is positive area. The area below the curve is, or below the x-axis is negative area. So you can think of that as a definite integral. You can think of a definite integral as just net change. Net change. Definite integral is, that's the shortest one we've come up with yet, is net change. You can call it a net accumulation of a rate of change if you want to be, want to get away from the geometry realm. It's a net accumulation of a rate of change. Be change in position is velocity, change in velocity is acceleration, but there it is in general. Definite integral is, oh yeah, that's the last one, is net change. Net change. Not necessarily total change, but sometimes it is when the values of the function are never negative. So net change is another way to talk about it. Okay, let's go on to the next page. Now, there's if you didn't get that, you can watch the video, or there's probably someone in your group who wrote it down. Now, there's 5 properties of definite integrals you're responsible for. First, if the upper and lower limits of integration are the same, then the definite integral has a value of 0. F of a minus f of a is 0. If you want to take the opposite, the bottom line is that if you're going from a to b, you can change it from b to a. I disclosed this to you earlier today. You can change the limits, the order of the limits of integration, as long as you multiply your answer by -1. Also, just like on the homework that was due today, suppose you want to find suppose you want just the area between the curve and the x-axis, and you don't want this to count as negative area, then you can start out by just breaking it up. Break up the integral from a to c. That's the part that's positive. You might want to treat that separately from the integral from c to b of f of x dx. So that's a pretty common thing for people who want to break it up into the positive area and the negative area, so that if you want to, maybe you can multiply the negative area by -1. Scalar multiples come out front. I have to tell you that, just to make it official. And also the antiderivative, or the definite integral of a sum is the sum of the definite integrals. So it's definite integral a to b of f of x dx plus or minus a definite integral from a to b of g of x dx. Now, those are the 5 properties of definite integrals. Just so you know, if someone really did want to find just the area of the blue region, the area between the graph and the x-axis, if you wanted to treat both of these as positive areas, then you would have to take the integral from a to c of f of x dx and subtract the integral from c to b of f of x dx. If someone decided ahead of time that you want basically total distance instead of net distance, or instead of displacement, then you would have to impose that negative sign on the negative area to turn it into positive area. So you kind of got thrown into the deep end when you did a problem like this on the homework. So you asked about it, I explained it, so now it's in your notes, and you're going to be seeing a lot more. So don't be surprised if you have to break up an integral into 2 parts dealing with the negative part differently than the positive part. So the homework that's due tomorrow is homework 4.6. The solutions are online. It's an online submission. When the bell rings, you're out of here.